Good evening, friends. Welcome once again to another session of Manthan. In this session, we are going to study about multiverse. Multiverse is basically the existence of parallel universes. It is proposed that apart from our universe, our own solar system, our own Milky Way, many galaxies, all the possible the universe that we recognize as celestial bodies, we recognize as universe. Apart from that, there are parallel universes which are similar to ours. They may not be similar, they may be dissimilar also. What is said is that they are characterized by their own physical laws. It is not just physics. They have their own chemistry, they have their own biology, makeup, constitution. So in a sense, each universe has a model of its own. So to understand multiverse, we need to understand the kind of model of universe that we are living in. And our model, there are many equations, mathematical formulae to suggest what our universe is. But we are now in the realms of infinity and nothingness, wherein these equations are also seem to falter. So it is better that we go to the most basic model. Let us say that our model is either the universe exists or the universe does not exist. When the universe exists, that means there is something is there. When the universe does not exist, that means there is nothingness. So let us assume for a moment, let us pictorially take a look at this, wherein that something is denoted by 1, binary 1, and the nothing is denoted by binary 0. So when you have something or nothing, this can also be pictorially represented as something inside nothing. So this something is the universe that we are a part of, and this is expanding inside the nothingness. That is the 0 that is shown here. So to understand this model of universe, it's important for us to know how this model starts, how it ends, and in between how it grows. Is there a chance of it ebbing? It's important for us to study all these aspects. So let us try and study what it is made up of and whether it is growing and what are the chances of it is ending. So this is the universe, the one something that I talked to you about. The constituents are just the way when you want to build a home, you need money, a plot of land and labor to build that home. In the same way, you need energy, space and time. Energy, space and time to build a beautiful universe. So obviously, energy, space and time become the 3 basic constituents. If you want to build a universe, those are the 3 basic minimum constituents. So Manthan presents them as this. This is 1, which is existence. Beyond this existence is nothingness, as is shown here. And this particular existence I have shown as the larger circle as the pure energy here. And then space and times are the subsets of the larger energy. Space and time, they feed on the pure energy, but the total energy in the system remains the same. As time progresses, space and time, they grow as they feed on energy. In the sense, the energy on the pure side is getting compensated. Now, this is what we call it as the basic constituent model of our model of universe. And we need to see whether this universe is growing or ebbing. So it was seen by Hubble during 1920 when he observed the celestial bodies in the night sky. He observed that almost all the galaxies were moving away from each other. They were of course accelerating and moving away from each other, suggesting that maybe sometime in the distant past, all of these galaxies which are moving away from each other would have started from a single point. And that point we know it as the starting point for our universe, which we call it as Big Bang. And this Big Bang is, since the entire mass or the energy of the universe is concentrated in a very small area, That is why it is we call it as infinite pressure and infinite temperature existing at Big Bang. And the classical model of universe also says that, you know, before the Big Bang, it's nothingness. This is 0, this is 1. So we need to now, we have seen that this universe is expanding. If this universe was expanding, and if it was just one Big Bang, in the sense nothingness, Big Bang, and then the universe expanding, and everything keeps moving away from each other, and maybe after a few billion or a trillion of years, you would see the night sky as dark. You would not see a single star because everything is moving away. This could be a possible option. Another option could be that this universe itself is collapsing on its own, and to come back to Big Bang once again, in the sense it is a Big Bang 2.0. Again, a new universe, cycle of universe starts. That means that the universe is more cyclical. So it is important for us to see whether there is a chance that this universe may collapse. So for that, we need to see how the space, time, and energy, the constituents of the universe, interact with each other. We had seen during the Manthan model of spacity that when you study the interaction of space with energy and all its forms. When I say energy and all its forms, energy in the purest sense, in the purest form, and then matter, life. So when you see its interaction with space, there is a negative effect, there is a decadent effect. So which means that the space has a negative effect on all forms of energy, whether it is pure energy or any other form of energy. And we had also seen during the Manthan model that this action of space on all forms of energy is derived from the mandate of spacity, wherein it wants to act on all forms of energy. And how it acts, we had seen it depends on the status of the mass that it is in, S1, S2 or S3 form. Now when you see this, this could be pictorially represented as this energy is the genie which has escaped the bottle of nothingness at Big Bang, and this space is trying to put all of this energy back into the bottle of nothingness. So when you have a representation like this in Manthan cycle, it is proposed, postulated in this particular cycle. So what we have here is the first part, of course, is the cyclic, the classical model of universe also proposes that from nothingness you have a Big Bang, and then you have space inflation where the space expands at a speed higher than the light itself, the speed of light itself, and then the universe is seen to be expanding. This part, this half is the classical model of universe. The next part is what is proposed by Manthan model, is that the space acting on all forms of energy, there will be a time when space, the energy that is related to space will be more than the pure energy magnitude, and that is when the space will tip over energy, and that there will be a possible time wherein the space will fight back and the space will win over its tussle with the energy. And when the space is fighting back, obviously the volume is shrinking, and obviously when this volume is shrinking, you can see that when it is being brought to the starting point of nothingness, that is where the volume is becoming zero. And volume is becoming zero, the pressure and the temperature are infinite. That means it started, the universe started with infinite level, and then when it is brought back, the energy, the pure energy in the whole system is restored. The infinite level of the pure energy is restored. So it is okay to have a proposition like this or a postulation like this, but it would always help if you have some theorems or some equations to try and analyze this. We could either come up with an equation of our own, Or rather than in reinventing the wheel, what we could do is try and see if there is any model which is a part of the classical model of universe, which is analyzed, studied, which we could use. When you see a cycle like this, where you have a big bang, space inflation, expanding universe, and the space fighting back and being put back into nothingness, you would see that this cycle is very similar to the IC engine cycle that we see either in a motorcycle or a car. So, and we know that it is basically a heat engine. So if at all we are able to convert this postulation into something similar to a heat engine, it is easier for us to analyze because the equations are already available. The CARNOT cycle explains it very neatly. So let us next go to the possible explanation that all this universe could be acting like a huge CARNOT cycle or an ideal universe. So in the ideal heat engine CARNOT cycle, we know that it all starts with point 1, where the spark plug ignites the air fuel mixture leading to the combustion, and this is the isothermal expansion, wherein the temperature is remaining the same, but later on obviously the temperature drops, but the expansion is happening here. But after this, the piston obviously tries to, once the air fuel mixture or the combustion cycle is finished, so it is all exhaust that needs to be sent out again, and this is where the compression happens. So obviously we know that the included area in this graph represents the work done by that particular cycle in one particular cycle, or the energy consumed in doing so. And let us try and compare these tasks that we see come across the CARNOT cycle with the one which we have just come across in the Manthan cycle of the universe. For spark plug, we can replace it with a big bang. The isothermal expansion, we can replace it with space inflation. And then we have the isotropic or the adiabatic expansion is very similar to the one which is expanding universe, where the temperature is dropping down, the universe is cooling, possibly the stage that we are in. And then we had suggested that the space is fighting back, and that is where the space is fighting back. This is where the exhaust of the IC engine is being thrown away. So the space is fighting back, and when the space is bringing the volume to zero, possibly the infinite levels of the energy are restored. Now, possibly this seems very similar to an ideal heat engine, and we could be able to use CARNOT cycle. But it is important for us to correct this graph by including infinity and nothingness. So we have seen that the Big Bang, it is a case of infinity, so it cannot be here. It will have to be on this curve, but it will have to be much farther away. For the sake of clarity or brevity, we have shown the infinity as here. And the rest, obviously it is okay, and when it is fighting back, obviously this cannot go to infinite levels on the volume, so it will have to be some time in between, somewhere in between, so that the space is fighting back. And when the space fights back and brings the volume to zero, and that is when the volume is zero, the pressure becomes infinite and the temperature also becomes infinite. So when you have a CARNOT cycle for universe like this, it becomes easier for us to analyze it because we know how the gases behave in an IC engine. We have PV is equal to RT, P for pressure, V for volume, R for the constant, and the T for the temperature. So let us see how this works out during nothingness. Nothingness is where you do not have any pressure, any volume, any temperature, no energy, no space, no time. So you would say that P is equal to 0, V is equal to 0, R is the constant, T is equal to 0. So the left hand side and the right hand side, 0 is equal to 0, which is fine. But what happens at Big Bang? At Big Bang, the pressure is infinite pressure. Volume obviously is 0 because it is brought back to the volume is 0. The temperature is infinite because the pressure is also infinite. What happens here is PV is equal to RT becomes 0 is equal to infinity. 0 cannot be equal to infinity, and hence we say that all laws of physics, they collapse. They break down at Big Bang, and hence that is what we call it as singularity, wherein these equations do not hold good. But in this Manthan cycle, there is one ray of hope. As you can see here, though I have shown the Big Bang here, Big Bang and nothingness are doppelganger. They are just side by side. So you can see that it starts with infinity, the Big Bang. Before that was nothingness, 0. And then when it is, the energy is restored back by the spacity fighting back, it is brought back to infinity. Somehow, here it is being shown that 0 and infinity are existing together. Possibly a case of 0 is equal to infinity. So let us try and understand the nothingness a bit more. 0. So we had this particular model where you have something which is expanding into nothingness, which is shown as 0. But when we are showing 0, we should not be showing any circle here because nothingness doesn't have any boundary. So let us remove that boundary. So we have just something, that is our own universe, which is expanding into nothingness. So we have 1 and 0 now as the only two entities in our universe. So if at all there is anything which is infinite in this, could something be infinite? It cannot be, because something by definition itself is finite. It has a boundary, so it cannot be infinite. The only thing which doesn't have boundary and which is an entity which is truly infinite would be the nothingness itself. So possibly there could be a reasoning that 0 could be infinity. We are not saying that 0 is equal to infinity, but we will try and see in the next slide how we can correlate them, how could they be coexisting. So what we are trying to say is, when the universe is driven towards infinity, the universe tends towards 0. So when the universe is driven towards infinity, the universe is driven towards 0. In the sense, when the pressure and temperature and the volume, you are trying to go towards infinite levels of the universe, the something 1. The pressure, when you are trying to move towards infinity, the pressure, as though this graph is bending and bringing it back towards 0. So what we have is an expanding universe. What are the chances of it reaching the infinite levels? Obviously, it has 3 options: the volume, pressure, and the temperature. And there is no way that the universe or the expanding universe can reach infinite levels using volume, because by definition volume is infinite. By definition volume is finite. Volume is equal to A into B into C. It is in cubic meter. Moment you say volume, it is finite. It cannot be infinite. So to say that the universe is expanding and it is going to a larger value and that is infinity is not really infinity. So what are the other options? It is then only to pressure and temperature. So when you have pressure as infinite, obviously volume will have to be 0. Now let that concept sink a bit. When you have expanding universe, the only way it can reach infinity is when the volume is 0. When the expanding universe wants to reach infinite levels, the volume will have to be 0. This suggests that the whole universe is cyclical in nature. Otherwise, this is not possible. In an expanding universe, volume being 0 is not possible. So we can put it in a simple terms that when universe tends to infinity, universe is driven into nothingness. And we are obviously saying that the universe tends to infinity, so I can replace universe with infinity, which means when universe is driven into nothingness, infinity is driven into nothingness. Now, when the infinity is driven into nothingness, nothingness contains infinity. In the sense, infinity is inside nothingness. So, which does say or imply that the nothingness now has the capacity to create infinity, because now infinity is inside nothingness. That is why it is said as infinity is equal to 1 by 0, because nothingness can create infinity. But that doesn't mean that infinity is equal to 0, because to reach nothingness, it is not a simple thing that you can reach nothingness. To reach nothingness, first you must reach infinity. Only you have infinite levels of the universe, which is infinite pressure and infinite temperature and zero volume. That is when you reach nothingness. So let us see what happened to the Big Bang and the nothingness. Obviously, nothingness we had 0 is equal to 0, and at Big Bang we had 0 is equal to infinity. What we are suggesting here is that at this particular point, which is basically nothingness and by the side Big Bang, 0 and infinity are coexisting. So to begin with, we had said that our universe model is 1 and 0. So to create our universe, you need nothingness and something. And when this something reaches infinite energy, is when you can create the universe out of nothingness and infinite energy, because this one is reaching infinite energy. And we had said that nothingness contains infinity when the universe is reaching infinite energy, which means that I can replace infinite energy with nothingness. In the sense, you can create universe out of nothingness. Literally, you can create universe out of nothing. Earlier we used to say that to create a universe, you need to have infinite energy. But it's not necessary now to have infinite energy. If you have nothingness, that is a sufficient model, because nothingness has the capacity to create infinity. And that is why we possibly say as Maya, miracle, wherein you can create this whole universe out of nothingness. That doesn't mean that we have nothing and suddenly you can be a billionaire. The concept of nothingness, you need to understand that you need to remove everything possibly in the universe that you can think of, energy, space and time. Only then you reach the universe, the nothingness. But you cannot just reach nothingness just like that. To reach nothingness, the whole universe has to breach the infinite levels of pressure and temperature. So what we are trying to say here is that the 0 has the power to create the universe. But to reach 0, the universe needs to reach infinity. And that is why possibly the Indian astronomers or mathematicians or philosophers express their interest so much in finding out what is this about 0 and infinity. Because understanding infinity, you need to go back to 0, because 0 has the capacity to create infinity. 0 is equal to 1 divided by infinity. Now, one may say that when you write something like this, 0, 1, 2, 3, infinity, how can 0 be equal to infinity? When you put that in the linear sense, of course it is not equal to infinity. But when you put it as a cyclical term, when the universe tends towards infinity, since the universe is cyclical, this universe is tending towards 0. Now you can also put it in a more physical form. If we have an outsider observing what is happening here, this something or the universe that we have is shrouded in nothingness. So for an outsider, what he sees is just nothingness. So you have the something inside nothingness, and it is coming into existence and it is going out of existence. For an outsider, he would never feel or take a look at this something being formed. So that is why we call possibly that this world is, the universe is all Maya. You can create it out of nothingness. Now let us see how this affects our understanding about multiverse, and that is what we wanted to study about. So what we are saying is, this is what the model that we had, the something which is expanding into nothingness. What we are trying to say is that this universe is not just single universe, there are multiple universes. So let us for a moment assume that there are multiple universes possible, or multiverses possible. So we are going to split them into many universes. Now let us assume one of these universe goes kaput. It goes out of existence. But the other universe is existing. It is still there. So when the other universe is existing, something is existing. When something is existing, you are not reaching nothingness at all. And for you to create universe, nothingness is basic minimum. So in this particular model, multiverse is not a possible thing. But who knows what are the ways of the creator? As long as the model of the universe is, the universe exists or the universe does not exist, the multiverse is not possible. One may say it is so simple, how is it possible that there could be any other model? But you never know what are the ways of the model. The creator may have some other models of universe where it is possible that the multiverse could be existing. But otherwise, with the model that we have, multiverse may not be possible. I hope it was interesting enough. Thanks for watching.